So this is theory and control, week 2, and we're covering material in chapter 2. So we're covering basic electricity in the book. I don't mind spending, guys, I don't mind spending 2 weeks on this chapter or the next chapter because it's the basis of understanding what is electricity. It's very essential for you to understand the basics because with that, it's going to mushroom into a lot of things. But if you don't understand the basics, it will be a little bit challenging. So, chapter 2 and 3 for me are the core material of this course. So I'll go as slow as possible. I'll repeat things as many times as you guys need. So basic electricity. Who took some physics in high school? Physics, no physics. Chemistry. Okay, good. We're close. We can understand each other. I'm gonna assume you know nothing anyway. So I'm gonna start from the basic, from the scratch. So we'll talk about the relationship between physical objects and electrons. What are electrons? What are these things that we call electrons? What's happening? And just humor me a little bit. I'm trying to simplify it, make it as easy as possible. But you don't have to understand the nitty-gritty. Just understand what do we need out of that. Why do we get that? What is this energy? What am I feeling? What's happening? It's kind of important. What is electricity? Where does it come from? Why do we need to understand electricity? Because for the longest time, electricity always existed. Physics has always been there. We did not discover gravity. It has always been there. We just knew how to put some numbers and how to work with it. So the more we discover things, the more we can work with them. Electricity has always been there. Wind was always there. The sun was always there. We're just getting to understand what's happening. We still don't know what exactly is gravity. We're still trying to find out what is gravity so they can find anti-gravity.
They're still trying to discover or define physics and unifying theory between general physics and quantum physics.
The thing is, like we think we know a lot, but we don't. We always try to humble yourself. We don't know much. We know whatever it's working out for us. We don't know why. So let's keep it simple. What is electricity? Why do we need to understand electricity? 4 types of electricity generation. How did we start to generate electricity and make it useful to us? Again, electricity was discovered 3,000 years ago by the Chinese and ancient Egyptians. They had batteries made out of lemon and acid. Chinese had a lot of electricity. People were fascinated with sharks and manta rays and eels because they have shocks to them. There are animals and insects that use electricity as a defense mechanism. That's like billions of years ago. It always has been there. The lightning that happens was actually people were fascinated by that. They thought it was God throwing lightning bolts on them and punishing people, which could be, I don't know. But it is a lot of huge power. At some point, Tesla was trying to see if we can harness this power and put it into wires and feed the grid, and we have free energy. He was onto something.
Didn't he do it?
Huh? No, they stopped funding him. They thought he was crazy and they stopped funding him. Westinghouse was funding him for a while.
They got rid of him.
Huh?
They got rid of him.
Ah, here we go. Here's basic theory again. Okay, let's stop here. So 4 types of electricity generation. How do we generate electricity? Conductors and insulator, and non-conductors and what are those? Okay. So this is a simplistic way to say all matters on Earth or in the universe are consisted of atoms. It's the simplest way to us to describe material. And of course, the atom consists of but this is like early science. Protons and neutrons. It's just a name for some objects they found in the atom. That's not that far ago, or within 100 years. I don't know, Rutherford or whatever, who found that the atom is apparently full of things orbiting, and there's a core here that has, he assumed has mass. And he gave the mass to the protons. However, when they used the Large Hadron Collider now, and they shot those protons and they cracked the proton open, they want to find what actually makes the mass. They found a bunch of stuff coming out, and they could not identify which one has the gravity. Recently, they came with some updates and discoveries. However, all in all, what we have to know for us, we're not going too deep. This is what we want to know. Every atom on Earth is consists of those three main things: protons, neutrons, and electrons. In reality, they're all just energy. There's no actual mass. This is the mind-boggling things for human. But there's no actual mass. This is all like space. It's space. People talk about, okay, what is giving things matter and weight and all this? Nobody knows. It's all things spinning around each other at different speed. So, to the layman person, let's just assume that this has the mass. This is the solid part of the atom, even though it's not. But for our intended purposes, okay, this part of the atom has the mass, and let it be done. And proton has a positive charge. And there's those things which basically they don't have weight or mass or anything, just charges running around the nucleus. They're running around, just charges. It's really hard for the mind to understand that charges are running. What is the charge? Just charge, just energy. Okay? And the reason they're running around is because they are attracted to the proton who has the same amount of charge in an opposite sign. These are minuses, these are plus. Okay, why do we need to know all this? Okay, because this is electricity. Electricity is a bunch of electrons running from one nucleus to another. It's jumping around. When you touch it, it's buzzing. It's what you're feeling. The jumping of electrons from one atom to another. You stick your tongue in a 9-volt battery, you'll feel that. If you touch a wire, you'll feel that. So that's what you're feeling, and it's good for the human mind to make sense of things a little bit. So let's just say that this is the basis of material, and this is how we have electricity. So on that basis, if all material has electrons, means that every material is conductive, right? Depending on how much electrons are in the outer orbit. So far, logical? Okay. This is what they call, I'm sure you're familiar with that, if you watch Big Bang Theory or anything. This is every nerd's poster in a dorm room. It's the periodic table. Again, it keeps growing. Basically, somebody went and organized all the elements around Earth based on the weight and the number of orbits of electrons around it. So we only saw 3 electrons in the other slide. There are some who has more than that. More and more. So again, these are the orders, these are all the materials that keep adding to it. From what we know, this part here is the metals. These are the semiconductors. And over here we have non-conductor material or gases. And let me just try to simplify that a little bit more. So if you look at it visually, if you look at an atom and electrons going around it, the closer you are to the electron, to the nucleus, the more gravitation you have to the nucleus, right? The further you are as an electron, you're very susceptible to be knocked out. And that's what happens with gold and silver. They have very high dense mass, but at the outer side of the orbits, we have one lonely electron who can be knocked out very easily. That's why it's easily can conduct material. And gold, dense, and metals are very dense and heavy, right? But they also have one lonely electron. If you look at the carbon atom, which is most organic material, it has 4 loose electrons at the end, but they're completely bonded. So it's really hard to move those electrons. They will move, but not fast enough. That's what makes metal conductor. So what do you need to remember? Metals, good conductors. Semiconductors, they can conduct, but not very well. You have to convince them to conduct. And non-conductors have very saturated, happy electrons close to the nucleus they don't want to leave. Fair? So we used to have 110. Last I checked when I made those slides probably 5 years ago, that was 118. They keep discovering new elements. And all those elements are available everywhere. They say 1 meter cube of seawater has all the elements in the world. Yeah. He's thinking, man, there's gold in seawater, right? Somebody thought of that actually. He did the math, see if he can extract that a little bit of gold from the seawater, but the process was too expensive. That didn't
A
make
lot of
sense.
energy.
Huh? Yeah.
A lot of energy.
It wasn't worth the gold I was gonna get. Do you know that you can desalinate water by freezing it? When you freeze water, it becomes pure water.
Seawater.
Yeah. So instead of heating the water to make it pure, you can freeze seawater, and that's pure water. Or you can go and steal an iceberg from the North Pole that's completely pure water. So water becomes pure when it freezes. It bonds to each other. The molecules for the water, they bond with each other. They don't bond with anything else. So you just get a block of pure strand in a desert island. You have a fridge. I don't know why. You can make a piece of ice and wash it because the salt gonna be on the outside. You have pure water. That's why also those double hump camels in Mongolia, they can eat snow. It's water. It's pure water. But it lower the body temperature. Anyways, so every element has different mass. What is mass? Is what we assume that the proton has. So we don't know what is mass at some point, but we assume that it's the proton. It has a charge. The charge is related to the number of electrons in the last orbit of that element. What's a molecule? Somebody?
Combination of atoms.
Yeah, it's a combination of atoms. So it's more than one atom. So one atom is just one. The simplest thing we can think of. Molecule is a combination of atoms. So is oxygen as O2 a molecule or atom?
Atom.
Molecule. Because it's O2.
Two oxygen.
Yeah, two of them. What about water? H2O. That's molecule. So whenever you have more than one atom as a substance, that's a molecule. So when the air around us now, what's in the air? Huh?
Particles?
What's in there?
Nitrogen.
Hydrogen.
Air, oxygen,
Oxygen. And what else?
Hydrogen?
Yeah? Nitrogen. How much oxygen? Percentage? Yes.
We only have
80.
You need to make it breathable for humans?
18.
Normal air, this air right now.
No, we're supposed to be 18.
18, 20. 20% of the air is oxygen. I should know that. You're a fireman. Okay.
Go there and get it.
What is what about the rest of it? What is it?
Mostly nitrogen.
Mostly nitrogen.
Yeah.
78 is nitrogen, 1% other stuff.
CO2.
CO2, yeah. As we breathe, we exchange the oxygen with CO2. So those are molecules. So H2O is a molecule. CFC, which is chlorocarbon, whatever that is, that was a refrigerant. And this other one. So these are also molecules.
What the letter stands for again?
They
I was
get long.
Chlorofluorocarbon.
Yeah, that's CFC. I don't remember C.
CFC, they use that with a lot of pressurized cans.
Oh yeah.
Yeah. This is a thing, it's a refrigerant. Don't worry, when you take the EPA test with Bill, he's gonna bore you to death with these things. Okay. So conduction. It depends on the number of electrons in the last orbits. Okay? And we said that conduction happens in material that's mostly metallic. Ceramics do conduct a little bit, so that's conduction. Silver and copper have one, so they're really good conductors. The best conductor, of course, is what? Gold. Second is copper. Second is silver. Third is copper. I don't think anybody can afford to have silver and gold as wires, so copper is a good one. What's after copper for conduction? Aluminum? Yeah. So there are wires made out of aluminum. So if you run out of copper, you can use aluminum. Insulators have 4 electrons in the last orbit of the carbon atom. They come in single and double. That means what's in the orbit here, gonna be singles, like this one, or doubles. And they spin around each other. They also spin around the atom. And all electrons are negative charge. Electrons are negative charge. They come in single and couple. The further they are from the nucleus, the more likely they will jump around and make current. Okay? Again, electrons, they have no mass, they have a charge, there's a field, and there's a frequency to them. Too much science, don't worry about it. This is how far it goes really far depending on the number of electrons. And the more mass the atom has, the more it will be able to attract electrons. It's kind of, if you think about it, kind of the sun. The bigger the sun is, the more it will attract planets around it. And they do the same thing, they spin around themselves, and they also spin around the sun. The whole thing is a big spinning body, I guess. Everything's spinning. Flow of electrons. Okay, here we go. So the flow of electrons is called electricity. The flow of electrons is electricity. And basically what we're doing is we're giving energy to the matter so the electron will be knocked out to the next one. Eventually, it has to be a circuit so it will come back, otherwise what is going to happen? It's going to flow. It's going to come somewhere. So, it's just like the flow of water. If you want to flow water in a circuit, you can. Or you can discharge water, which like you have a cut-off pipe that's kind of discharging a capacitor or discharging lightning into earth. So, friction, the ways we can generate electricity either by friction, chemical means, magnetic, and heating simple mirror. These are the 4 ways where we can make current or we can make electricity. So friction, remember when you have a balloon and you rub it through, I guess, your hair and it sticks a little bit?
I just had a question, because that was the last one, the last question on the quiz, that one right there, and I just kind of got confused. So the ones that came out with like nuclear, coal, natural gas, that's just like types of electricity, or that's just, this is the main ones?
These are the main ones, how to generate electricity.
So what will those be over there? That would be types, or, but this is the ways to create
Yeah.
electricity. So those like, hydro, nuclear, coal, natural gas, all that, what would
No, these are means.
Those are means?
Yeah.
Okay.
I'll explain to you
Yeah,
how.
but that's what, that was kind of had a hard time.
Which one of those? Yeah.
Figuring out, that was in the last question, in the last first homework.
Good question. These are the 4 ones, 4 main ones to generate electricity.
Okay.
Friction. Friction is not reliable. Why? Because there is no flow. It's like static electricity. One touch and it's gone. There's no flow. It's only discharging a charge. Chemical. We'll talk about this elaborately. What is an example of a chemical reaction that causes you to have flow of electricity? Battery. That's chemical, right? And batteries can be reversible or irreversible. So you can charge it and discharge it based on chemical reaction. Magnetic or magnetoelectric. What is that? Huh? Say again? Generators. What else? Yeah. Motors, alternators. So you gotta turn something which changes mechanical power into electricity. Again, energy does not vanish or comes from nothing. Always think about that. So it will transform from one form to another endlessly. So that's magnetic. That was the most genius way to generate electricity. If it wasn't for the magnetic or electromagnetic, we would never have the power generation that we have now. Heating similar metal, we talked about that. It's we did. Thermocouples. Think about thermocouples and small wires. When you touch 2 similar metal, like copper and nickel, for example, and you heat. So what is heat? When you heat something, what are you doing? What do you think you're doing? Think now about the electrons.
Flowing the electrons.
You're making them vibrate more. They keep vibrating more and more, and they make frequency. So if 2 metals stuck together and they are not vibrating at the same rate, they are different rate. What do we have? Potential. We have high pressure and low pressure. We're gonna have flow. We have voltage. Yeah. We're gonna have You're gonna create electricity by doing that. Does anybody do camping? When you go camping, you know about the thermal pots? So you go camping, you make a fire, and there's a pot that you put in there that will charge your phone. While you're making tea.
Never heard of that.
Don't let my wife know.
It is there.
I usually just leave the phone and go camping.
Huh?
I usually just leave the
Well, you
phone.
can charge your flashlight. But heating similar metal is another way to make electricity. So static electricity, I'm gonna go over them one by one. It's caused by friction. So in the winter, when you walk over carpet and you touch the doorknob, that is basically static electricity. Your body is borrowing charges from the carpet, from the air, especially in dry air. And when you touch a metallic part, it will conduct and discharge. But there is no steady flow, so it's not really possible to make current out of it. So it's just a charge coming out. Once it's balanced, there is no more flow. So you are carrying fuel of negative charges. For example, the balloon example, I don't know if you did that when you were young. You rub the balloon to your hair, you touch the floor, it will stick there for a few seconds and it falls again. The balance has been achieved and there is no more charge and it will fall. And let me write down something that is important for you to understand. It's called the law of charges. Opposite charges attract, similar repel.
Is B or P?
Repel each other. So when you have positive and positive, it will repel. If you have positive and negative, it will attract. So once it bounces, it's going to be discharging. Remember the magnet? When you have two magnets together, if you have north and north, it will push each other. North and south, they will click. And if you break it, it's going to depolarize again. That's again the positive and negative, north pole and south pole, etc. So it will balance itself eventually. So that is static electricity. You have charge, opposite charge will attract to it, otherwise it will repel. Okay. Question about static. We understand static, we're not going to use a lot of it. So, but we understand this is one form to make electricity. Some people try to use that as to make current out of it, but it was not practical at all. Chemical electricity. It's the battery. If you ever dissected a battery, probably you'll have an idea of what's in it. Basically, it's a byproduct of a chemical reaction, like your car battery. What's in it? Acid and two metals, right? Lead and nickel or something else. And basically, when you connect the battery together, those two metals come in contact. And what is the acid doing? It's basically electrolyte, right? So those chemicals will reunite, and the byproduct is current until it drains out. Then you charge it, which actually what you're doing is a different reaction. Over time, whenever you have a battery, over time there's always something called the cycling period. You don't have 100% reversibility, right? You gotta charge and discharge every time there's 0.5% of something else happening. New product taking place. So over time, you buy a battery. They tell you after 2 years you're gonna have to change this battery because there's no more the same material to start with. It's not completely zinc or lead or whatever. You have a new product coming up, and this is gonna take over the battery, and eventually you have to change it. Your phone. When you buy your phone brand new, the battery stays 2 days, right? Or at least a whole day. You don't have to charge it. 6 months, it will start dropping. And in 2 years, probably you have to keep it plugged in the whole time, or you have to change the battery. Because again, every time the lithium ion inside is having a byproduct of something else. So it goes through recycling, of course, and they try to get the materials back if they can. Otherwise, they try to discard them. So we have two electrodes and we have electrolytes. Whether it's acid, paste, whatever it is. You don't have to remember this too much, just what is the component of the battery. Chemical reaction produces a flow of electrons, and this reaction is calculated because the battery tells you this is the amount of voltage, this is the average for a while until it starts to drop the voltage over time. But it will guarantee you to have this milliamp or millivolt over a period of time until it starts to drop and you have to change the battery. But for a long time it should be controlled. Otherwise it will be complete reaction quickly, not over time, and it's gone, and you have drained the battery completely. And that's what is called the capacitor. A capacitor holds a charge, but it discharges quickly. It's not like a battery. That's a capacitor. It holds 480 volt charge, but it comes all at once. It's kind of like a battery. Difference, the battery takes its time. Probably this is a battery that's going to discharge over a few hours. The capacitor will let go of the entire power in microsecond, completely coming out. So dry cell battery is the energizer battery. Made out of zinc, has a negative electrodes, and gave away electrons. There's manganese dioxide paste. Did anybody ever like take apart a battery out of curiosity?
Take part of battery.
Yeah.
No,
Small never?
no, I haven't.
Never occurred to you at all?
I thought about it. I didn't know if it was a good idea.
Hey, kid.
You like it, doesn't that much?
Every time I play with the toys and find a battery, I have to take the battery apart and like fill the room with paste, and I get a beating because it's like this paste that doesn't go away, and it's very dangerous. You're not supposed to do that, but it was always one of my hobbies. They're going, oh look, and I always have the illusion that I'm gonna bring it back to life. It doesn't happen. So manganese dioxide, that's the black stuff inside the battery, and the carbon rods collect the electrons while they are reacting and doing something else, and that's a dry cell battery where you cannot recharge it. Rechargeable batteries have different material, and they always react and react. You charge it, you will have some different product. When you discharge it, you have another product. For the battery to work, it has to be connected. Those two have to get in contact with each other, and here's the substance that's going to be consumed. What else do I want to say about the batteries? What kind of voltage comes out of battery, AC or DC?
No,
DC. This is direct current. It's going to be always positive and negative, right? Either positive or either negative. But usually it's negative. Because what charges are electrons? Negative charge. So this is actually the outcome. It's the output, the upstream, and goes into the positive. Okay? So we know about batteries, we know about friction. Thermoelectric is the third one, and people are trying to capitalize on it now, trying to find ways to generate electricity. But all these do not give us enough power, even batteries. Until recently, until they come up with the Tesla batteries, it's not that effective, you know? I mean, now it's getting much better. But for the longest time, nobody was able to make a battery that's efficient, that will run a car, run an engine. So, thermoelectric is still very little. It converts heat into electricity using the similar metals. So the bimetal and the thermostat does the same thing. People are always coming with new types of alloys. This is the guy who came up with the idea. I thought about it. Heat generation in conductive material, if they're the same, it's going to generate heat and generate electricity. However, the current always varies, and it has different kind of different current means. You have voltage, and they always require calibration. What does that mean? So, if we have two similar metals, they're not going to be always giving you the same amount of voltage over time. At some point, it will need to be calibrated, or getting used again. You're gonna have some kind of byproduct over this two materials, and it's not going to give you the same current. It's not an efficient way to produce electricity at all, unless it's very small amount. And people are still doing some research to make it better. I mean, it is possible, but it does not give you the same amount of voltage you can get from a generator, or an alternator, or something mechanical, wind turbine. And we'll talk about that.